Consider this integral from n to n plus 1 by x dx. And we need to prove this result for n positive, right? So this is the function given to us, and because this is a rational function, so it is continuous in the given interval n to n plus 1, the closed interval, right? How to know that this function is a continuous function? First of all, this is your rational function. Every rational function is continuous everywhere in their domains except at x equal to 0. Because at x equal to 0, the denominator becomes 0. And when the denominator is 0, the function is not defined. तो function को continuous होने के लिए सबसे पहले define तो होना पड़ेगा. So for continuity first, the function should be defined. And because here interval is n to n plus 1, where n is strictly positive, it is given to us. So fx is continuous everywhere in this interval, right? So therefore, f of x belongs to Rx, that is the set of rational functions, in closed interval n to n plus 1. Now also, for x belonging to this closed interval n to n plus 1, to find the least upper bounds and greatest lower bounds, we need to make this x to be 1 by x. Let's take the reciprocals of this all over. So it is 1 by n, this is 1 by x, and this is 1 by n plus 1. And when taking the reciprocals, the sign changes. So fx is less than equal to 1 by n. Or we can also write this as f of x is greater than equal to 1 divided by n plus 1 and less than equal to 1 divided by n. So fx is bounded in 1 divided by n plus 1 and 1 by n. So therefore, f of x is bounded in closed interval n to n plus 1 and is also monotonically decreasing in the same interval. How to know that the function is decreasing function? Please note that if the derivative of fx is strictly positive, then the function is increasing function. If the derivative of fx is negative or strictly less than 0, then the function is a decreasing function. And if f dash x is equal to 0, then the function is constant function. So in our case, fx is 1 by x. What is the derivative of fx? It is minus 1 by x square, which is strictly less than 0, right? So our function is a decreasing function and it is monotonically decreasing in the closed interval n to n plus 1. Now to get the least upper bound and greatest lower bound of fx. Now because fx is bounded in these two, so taking this to be small m and this to be the capital M. So this is 1 divided by n plus 1 and this is 1 by n. And we know one result that m into b minus a is less than equal to the integral of f of x from a to b and is less than equal to capital MB minus a. This is a result I'm going to use now. So what is small m? It is 1 divided by n plus 1. It is 1 by n. So this is 1 by n into n plus 1 minus n. So this is 1 and this is also 1. So we get 1 divided by n plus 1 less than equal to the integral from n to n plus 1 of 1 by x dx less than equal to 1 divided by n. Solving this integral, what is the integration of 1 by x? It is log of x and the limits from n to n plus 1. So this is log of, putting the upper limit, minus log of n. Now log of a minus log of b. This is log of a divided by b. So this becomes log of n plus 1 divided by n. Or we can also write this as log of 1 plus 1 by n. This is what is needed to be proved. So we have proved this result for n positive. Okay, thank you.